Hi everyone, today we are looking at a question like that. The first thing I want to do whenever I solve a math question is to identify the keywords. Now, look at this. It is a very long sentence. The keywords that I see is the word equal to. Okay, now when I see equal to in a fractions question, I know that this concept is what we call equating numerators. Okay, equating numerators. Okay, so some of my students, they will just write down en. Alright, so sometimes we'll just write down en. Okay, now the next thing we want to do is to read the sentence part by part. Okay, not as a whole. Okay, so we are going to break down the sentences. There were 255 more cars than motorcycles in a car park. So this is sentence number 1. Okay, so I know that cars is actually 252 more than the motorcycles. So this word over here, more, tells us that their difference is actually 252. Okay, so once I'm done with that, I'm going to move on to sentence number 2. Sentence number 2 says 1/4 of the number of cars was equal to 3/5 of the number of motorcycles. Now, what does that mean? You first have to write down that cars, okay, is equals to 1/4, okay, and for motorcycles, it is 3/5. Okay, because they say equal to, it means that the numerators have to be the same. So what you want to do is to make the numerators the same. Okay, why is it that the numerators have to be the same? Because of this sentence too. It says that equal to, right? So that is trying to tell you that a part of the cars is equals to a part of the motorcycles. Okay, so what you're going to do is you're going to write out the new fraction. Okay, and the new fraction, as you can see over here, is 3/12 is equals to 3/5. So what I'm trying to say here is that a part of the cars is actually equals to a part of the motorcycles. Do they have the same total? No. Okay, a part of the cars is equals to a part of the motorcycles. Okay, now the next thing you want to do is this. Do you remember just now in sentence number 1, it says that there were 255 more cars than motorcycles in the car park. So we can actually infer from that, sentence number 1, that the difference, okay, is actually equals to 12 units minus 5 units, and that gives me 7 units. And what is 7 units? 7 units is simply 252. Okay, so what you want to do next is you want to find 1 unit. Okay, so again, whip out your calculator. Okay, just 252 divided by 7, you get to our answer 36. Okay, once you're done with this, okay, I tell my students that this 1 unit is what we call Mr. Green Man. What is Mr. Green Man? Mr. Green Man is simply a hint for you to read the question. Okay, a hint for you to read the last sentence. Okay, when I say question, I'm referring to the last sentence. Okay, now, so once 1 unit is out, you can actually read the sentence. The sentence is, how many cars and motorcycles were there all together? Since they are asking us for all together, we have to look at the denominator of the car and the denominator of the motorcycles. So from here itself, I can see that it's 17 units. So all you need to do is just simply 37 times 17. Okay, same thing. Whip out your calculator, you can calculate. You get to this answer of 612. Okay, and therefore this is your answer for this question. The answer is 612 cars and motorcycles altogether. Hey students, I hope you understood this video. Alright, now the rule of thumb when it comes to solving a math question is always to make sure you identify first, break down the sentences, write down what you know, find Mr. Green Man, which is known as 1 unit, and from there you will eventually get to your answer. Okay, so I'll see you in the next video. Bye!